Okay, so I like to do a little demonstration of queries before students are required to do a lab quiz. The queries have been covered in this class in a few different places. It was actually covered in the very first module. The assignment from the Esri training online had a little query right in the very first getting started with GIS module. We didn't tell you a whole lot about queries in that module, but it was just a little bit of introduction and using a GIS to actually answer questions by performing queries. So we then talked about queries again in Module 5 when we looked at selecting features. Performing queries are one way of selecting features. You can also interactively select them. Solving spatial problems has some queries in it too. And so we have a lab quiz that is all about queries. And what I do is I make this lab quiz information available to you with some sample questions so that before you go to take the quiz, you should download the data, familiarize yourself with the data, and do the sample queries. What I've found in the past is that if I did not provide the data for the quiz, students oftentimes had trouble getting the data downloaded and opened and understanding what data they were using and what attributes were associated with that data before they opened the quiz. So it was a kind of an additional hurdle to students for getting started on the quiz. I find that giving out the data and some sample questions allows students to familiarize themselves with the data and do some sample queries so that when they go to do the lab quiz, they are at a minimum familiar with the data and ready to do some queries with it. So there's a few kind of stumbling blocks with downloading and working with some of this data, and so I like to demonstrate this straight from the download and talk it through and then do a few queries, and we'll look at these sample queries as well. So when I go to download this data, it's going to drop it into my downloads folder, and on these computers we have a program installed called 7-Zip. So when I go to unzip the file using 7-Zip, you'll see a graphical user interface that you may or may not have on your personal computer. You can unzip zip files without using 7-Zip. The Windows operating systems do it automatically. You do not need a third-party application like 7-Zip to unzip, but we do have 7-Zip loaded in these labs. So this data for the City of Greenville can be downloaded from the City of Greenville, South Carolina website. I believe they make the data available as shapefiles. I have incorporated the data into a geodatabase here, a file-based geodatabase. And so when you unzip data, this is something we do with your File Explorer that comes with your operating system. So when you download a zip file, we need to unzip it using your operating system or an application that unzips it. This is not a GIS task is the main point. So before you go into the GIS software, you've got to unzip this thing. And so hopefully you all have a folder for this class, something like GIS 111, or you may be in my CEG 111 class. And so I'm going to create a folder called Lab Quiz in my GIS 111 folder, and when I go to extract this zip file from my downloads folder, I'm going to tell it to extract it, and I'm not going to let it go to the downloads folder, which is its current location. I'm going to have it extract to my documents, GIS 111 Lab Quiz folder, and just like that, it should have worked. Now, how do you know if it worked? If I go look in that folder, Lab Quiz, I see here's this GDB folder. Now, this is a file geodatabase. If you remember back from when we talked about file management, you should not use the File Explorer, the operating system file manager. It's called File Explorer. It used to be called Windows Explorer. You should not use the File Explorer to manage your GIS data. the file management tool here that we're looking at that comes with your operating system is a great file management tool if you are managing things like Word documents, PDF files, text files, JPEGs. Those are data formats that the Windows operating systems are used to. The GIS data formats are slightly more complex than these types of other data formats. A GIS data format, like the file geodatabase for instance, if you open it, it looks like it's a folder on the hard drive, but if you open it, you see all these binary files. And if you try to double click one, the computer doesn't know what to do with them. So this is actually just a file geodatabase, but it's made up of a lot of different files. So to view and work with GIS data formats, you work with ArcCatalog. Be very careful in this folder with a .gdb extension. Because it's the operating system sees it as just a folder on the computer, you could actually save other files to this folder. You could save a Word document into this folder, or you could save a map document into this folder. Don't ever do that. This is kind of a hands-off folder. Stay away from it unless you're interacting with your file geodatabase through ArcMap or ArcCatalog. So if we open up ArcCatalog and go look at this file, this file geodatabase, you'll see it's going to look very different in our GIS file management tool, which is really ArcCatalog. Is how we manage our GIS data. So let's go look in my documents folder, GIS 111, lab quiz, and that geodatabase there is actually this. Okay, so you see the actual feature classes that are part of it. So it's a way that Esri has encoded a bunch of information into a set of binary files that you need to view using their software, ArcCatalog or ArcMap, in the desktop environment. You could also use ArcGIS Pro if we were using it. So that's downloading and looking at the data and getting it ready to be used. So you kind of have to do some stuff in your File Explorer to get the data extracted, but once it's extracted, jump right over in here to ArcCatalog to look at it. So I'm going to crank up ArcMap, and we'll just jump right into the queries. Now, you may see a reference in the quiz to something being called like building_p.shape. I used to provide all this information as shape files, so if you see a reference to a shape file, just know that the data now I have stored in a file geodatabase. Let's make it where we can see this a little bit better. I'm going to close some of these windows, and I can actually close the standalone ArcCatalog altogether, and let's just use ArcCatalog here embedded in ArcMap, and I'll try and make this so we can see it a little bit easier here. Alright, so the very first question, how many buildings are accessory structures? So if we look around at the data, I'm familiar enough with this data that I know that the buildings data is in a file called build_p. I guess that probably meant building_polygon for the person that built it. Drag it over here into ArcMap, and you can see that this is what the city of Greenville looks like. So if I open the attribute table for the buildings layer, I can see there's a use field, and that use field has information like accessory structure, temporary code, single family residential, commercial industrial. You start to see there's a lot of values in here for it. If you want to know all the values, there's a frequency tool you can run in our toolbox that'll show you how many different values there are for use and how many occurrences there are for those. And you can also, if you symbolized it based on that category of use, when you add all the values, it gives you a quick feel for how many different values there are for that. Now this is kind of a quick and dirty shortcut too to see how many values, how many occurrences of each one of these there are. Like there's 76 courtyards. There's 10,394 accessory structures. So this is not really a query, but the functionality of symbolizing by use using categories, non-numeric data, categorical information, qualitative information. It shows you the count there. So that's kind of cool. And at least tells you what kind of values you've got here as well. So you don't have to symbolize it, and it doesn't matter that I did or didn't. I really just wanted to show you that. The real point is that we use our attribute queries to select use equals accessory structures. So let's remember how this select by attributes dialog box works. Remember, it builds SQL, structured query language, and that is a standard language for manipulating databases. And this GUI builds SQL for you. The way it works is you have to double click the field that you want, you single click the operator, and then you can get all the unique values for that field, and you double click the value you want. If you are querying for a field that holds text or string information, that value must be in single quotes, and you get that by picking the value from these options here. So if I click apply, it selects them. Notice the little number pops up down here, and that number looks like the correct answer from our document here. Now, that number you have to be very careful of. Notice it goes away, and we'll talk about why that number may or may not be correct on a future query coming up. Another way to look at your results are by viewing your layers by selection, and you can also open the attribute table and see how many 10,394 of the total are selected. If you want to know if it worked, an attribute query, to determine if an attribute query worked, the best thing you can do is open the attribute table and look and see if any values are selected that shouldn't be. It looks like they're all accessory structures, so I'm pretty confident that that one worked. So the next question, how many accessory structures are greater than 1,000 feet? So we could do this one of two ways. We can either build what we call a compound query statement or a multiple criteria query statement, where you put a use equals and an area greater than in one statement. We could also change our selection method here. If I go to select by attributes, since I have a selected set of all the accessory buildings, I could select from that current selection where area is greater than 1,000. Now, the area field is going to have all unique values almost. There may be some that repeat, but since it's the area of a polygon, you'd expect that almost all of the 38,000 would be unique values. So when you're querying for a number, we often don't click get unique values because it will run for quite a while to get all the unique values. You can just type it in. Numbers do not require there to be single quotes around them like text. As a matter of fact, you can't put the quotes around them or it won't work. So we could do it that way, but instead, let's clear our selection and let's look at a compound query statement where we can select by attributes, and this time we're going to select for use equals accessory structure, and let's look in the area field for greater than 1,000. So you have to put in and area greater than 1,000. So this is a statement that will evaluate two different fields, one for use equals accessory and area greater than 1,000. If I click apply and we look at these fields, it looks like all the areas are now greater than 1,000, and it looks like they're all accessory structures. So you can start to get a feel that it looks like that query worked. It says there's 493, and That's what I show the answer as over here. So that's a compound statement. Now, let's jump away from this sample questions here, and let me show you another one. Let's say we wanted to look at all the residential. Now remember, when we looked at area and use, that is across two fields, and we used and. If you're looking for multiple values within one field, like let's say we wanted to select all of the parking structures and schools. That's two values within one field. If you're searching like that, you use or and not and. And so let's just look at that. I'm going to select by attributes. I'm going to clear my statement. And I want use equals parking or use equals school. Now, a lot of people will put and in there, and a lot of people will not put use in there a second time. If you're searching for multiple values, school and parking structure, within the same field, use or. If we click apply and we open the attribute table, let's look and see if we think it worked. We've got schools and parking structures and schools and parking structures. I think it worked. Now, why do you use or there? The query expression evaluates that statement one individual record at a time. It looks at that cell outlined in the black, and it says, is that use equals school, or is that use equals parking structure for that one? And is it use or school? Is it parking or school? Yes, it is. If it said and, that value is never going to be school and parking structure. Okay, so that's why it's or and not and, because it looks at that one cell and it asks that question. All right, so that's another multiple criteria query statement using or within one field rather than and across two fields. Okay, so right on to some location statements. So the next one wants to know how many parcels are within a quarter mile of a bus route. So we've got buildings turned on. We don't have parcels loaded, and we don't have bus routes loaded. Okay. So, take time to turn off the layers you're not using. Take time to symbolize it a little bit so you can see what's going on. Make sure that it makes sense to you what you're looking at. I don't like that dark black on the... Alright. Okay, so how many polygons or how many parcels are within a quarter mile of a bus route? So if we go to select by location, you need to really pay attention to the difference between your target layer and your source layer. Read the dialog, select features from one or more target layers based on their location in relation to the features in the source layer. So we're going to select features from parcels because I asked how many parcels are within a quarter mile of a bus route. So we're going to look at how many features in the target layer are selected based on their relationship to the source layer. Now we want to know the ones that are within a distance of. If you remember from our talk about queries, when you're doing for the purposes of this class, ignore anything in parentheses that says 3D, Clementini. We use the ones that don't have the parentheses. We are going to search within a distance of the source layer of a quarter mile. Don't put 1\4 like it states here. The query won't work with that. You have to do 0.25 miles or put in how many feet a quarter of a mile is. If you click OK, it goes through and it selects them. Now, number of features selected, notice it just says greater than 20,000 here. but it should be 19,932. Why is this number so high? I don't think it's right. Is that number wrong? That number is wrong, but that is the total amount of, that number doesn't show you how many are selected in one layer. It shows you how many features are selected in all the layers. So buildings underscore P, the buildings layer that is now not displaying, it's unchecked, it's just not turned on. There's still selected features in that layer. And so the number that flashes down here is the total number of features selected in all the layers. So just be aware of that. That number is not the best one to look at. You need to look under here to see how many features are selected, or open the attribute table. I could clear this layer selection, and then you'll see that that's the right answer. Now, why is that not quite the right answer? 19,933, where it's actually 19,932. There's one extra polygon. This layer I'm looking at, which I'm pretty sure yours does not show this, it's a little bit weird, and it's kind of hard to work with, because it's not hard to work with, it's just a little misleading. Because does everyone see this polygon that looks like a road right-of-way? That is one polygon that goes throughout the whole layer. So when that thing gets selected, watch what happens when I select that one polygon there. It selects, that is one polygon that is continuous and runs out through the whole city. So it makes it look like there's a lot of things selected when it's actually not. The data that you download, I am pretty sure that polygon has been deleted out of it so that it is less confusing. Okay, but that's just something I wanted to point out. A lot of people see that, and when you select all the features within a distance of that bus route, quarter mile of the bus route, it looks like everything gets selected because of that one polygon that runs all through it. So it looks a little misleading, and something to watch out for in your data, or at least to be aware of. All right, let's see. What else? How many buildings are within a quarter mile of the airport? So let's turn the buildings layer back on, and then let's load in the airports. All right, so this airport is the municipal airport in downtown Greenville. It is not GSP, Greenville Spartanburg International Airport. This is the little airport downtown. And for this scenario, let's just say that the airport was going to, or would like to build a new runway. And so they have submitted a permit to the city to do that, and the city has said, well, you need to let folks know who are close to the airport that you're planning on doing this, so we can get feedback from the public, from the people that live near it. And so they said, okay, well, let's contact all the people that are within a half mile of the airport. So let's select by location, and let's select features from buildings that are within a half a mile of the airport. And if I click OK, it does that. All right, you see a number flash down there below, 2121. That looks like it's the answer from this. Let's look here to confirm, make sure there's nothing else selected anywhere. Nope, so there's 2,121 buildings within a half a mile of the downtown airport. Okay, so they start to send a letter out to everybody, but then they look at the fine print from the city, and the city said, well, you need to send a letter to the people who live within a half a mile, not every building. So the commercial buildings they're not worried about, they want them to notify the residences near the airport. So if we look at the buildings layer, 2121, there's multifamily, single family, there's also accessory structures, commercial, industrial. So now that we've done a location query, we want to use an attribute query. We want to select by attributes. From this table, we want to select from those 2,121 Sorry about all the desktop notifications. You want to select out of these 2,121 buildings within a half a mile of that airport. We want to select from those 2,000 plus, select from those current ones where use equals single family or use equals multifamily, or either way. You can do it in either order. I just did it alphabetically. Okay? So let's move this out the way if it will, and let's watch what happens when we apply it. So a lot of the buildings really close are already some kind of commercial industrial buildings, but these residences, single and multifamily, are not too far away. Okay? So that's adding a attribute query to a location query. Alright, the final thing that I want to show you is looking at, well, maybe one or two more things. I want to show you the council districts and address points. So we don't have either of those layers loaded. I'm going to turn everything off and clear my selection. I'm going to load in the council districts, and I'm going to load in the address points. And here it is. So, you work for a councilman who wants to send out a letter to everyone in his district. So how is he going to do this? Well, if he's got the address points in the council district layer, he should be able to select all the address points within his district or her district and do a mail merge to send a letter. So, we want to know how many address points are in council district 1. Now, if you just look at this layer, you see 4 big polygons. So just looking at it, it kind of looks like there's probably 4 council districts. Okay, but if you open the attribute table, you see, well, there's an object ID with all these numbers. I mean, maybe there's 22. There's 22 polygons. Maybe there's 22 districts. This object ID is a system field. It's how ArcGIS manages the relationship between each feature on the map, polygon in this case, and the attribute that describes that feature on the map. So this number, if polygon 5 gets deleted, object ID 5 won't exist anymore. Okay, and you create a new polygon, and these numbers can change based on the system. You'll also see some other numbers like these sometimes. These are old system IDs too. What we want is the district field. We want district equals 1. If you look, you can pretty quickly see that district 1, 2, 3, a bunch of zeros, a 4. So, what's the deal? Are there 4 districts? Is there a district 0? So, this is the kind of thing that happens with GIS data a lot. It's hard to understand exactly what's going on with it, but using data and having experience helps a tremendous amount. In this case, district of 0 is no city council district. The districts of 0 are little holes in the city that are owned by the county. They're where the city has grown around the county but never annexed that part of the county. So if we select some of these zeros just to see what they look like, I'll just select the ones below that 4. You'll see there are these little holes in it. Okay? So, what we want to do is select by attributes, clear for council district, district equals 1. So that's the district 1 up there at the top. So if you turn on the address points, you want to select the ones in that selected polygon. So now if you do a select by location, you can select features from address points that have a spatial relationship with council district, and we want to do intersect. How many address points intersect the council district layer, but not the council district layer, that one selected feature in the council district layer? And let's also uncheck the search radius. We don't want that. We just want the ones that fall in that selected polygon. Now, intersect will select all the points that touch the polygon, even if they touch directly along the edge or the boundary. If we were to say select all the address points that are completely within, it would select a very similar number. It would not select ones that touch the actual boundary. In this case, no points touch that boundary, so they will both give you the exact same answer. Click apply. You see it selects all of those there. You see that number that popped up, 4209? Is that how many address points are selected? No. That's how many address points are selected plus that one council district polygon. So how many address points are in council district 1? 4,208. Okay. Okay. That is some demonstrations of queries and working with the quiz data that you'll be using for the lab quiz. Make sure to download the data, review the data, understand the data, perform the sample queries before you go into the lab queries quiz here. Because once you start this, when you go to attempt the quiz, it's going to show you 10 questions. And it's multiple choice. All you do is pick an answer. So you want the data loaded into ArcMap, ready to go, or at least you don't have to have it all loaded into ArcMap. You certainly don't want all the layers in ArcMap turned on because it gets confusing. Make sure to turn layers on and off as you need because it's just too much data to look at. It's hard to evaluate if the query worked when you've got 8 layers turned on, 6 of which don't have anything to do with the query that you were performing. So we're going to change the quiz date a little bit for this class. For whatever class you happen to be taking, if you're watching this video, make sure to look at the due date and understand when you need to get yours done.